All right, good morning, everyone. My name is Aminah Siddiqui, as she introduced me. I just completed my freshman year in high school, so just next month I'm going to my sophomore year. Um, Today I'm here to present to you my innovation project LESAR. And before I begin, I'd really like to thank AIAA for allowing me to be here today and have my own booth at 306. It's been such a great opportunity, and I'm really excited to be here today and learn from you all. All right, now a little bit more about myself. As I said, I'm going into my sophomore year. I am passionate about space, as you can imagine, STEM, and art. So actually, since the first grade, I've been participating in various robotics programs. That's me over there, if you see. And then I've had the opportunity to mentor elementary and middle school teams at my school. And then just this year, I was a founding member of our school's FRC team. Over here, you can see, just last month, I went to the Grand Canyon for the annual star party that they had. And my father took this photo. It's really amazing to just lie down and look over at the stars. And sometimes I like to express that in art. As you can see, I did kind of a modification to the Starry Nights. I find it's one of my favorite paintings, and I was able to do it with colored pencil. All right, so how am I here today? So this project actually just started off as a high school science fair project, and I was recognized over other various awards by the AIAA San Diego Chapter Award, and that's how I came to know of this conference. So I shot them an email. I was like, hey, do you think maybe I could attend? And so they were kind enough to give me a booth and to be able to talk with you guys here today. So what does LESAR do? We're planning on reimagining space exploration, but we need to understand what that is as of now. Space exploration is, as we all know, expensive and time-consuming, and that being because of longer mission durations. As you can see from the data, we have billions of dollars going into each mission, but there are also longer times over decades. And so with that, of course, it takes longer to develop and to ensure that these missions are going to be performing at their utmost best. But then with that, we also realize that the cost of failure is very high. Take NASA's Viper, for example. They had started working in 2020 for about 4 years and about $450 million, but due to various reasons, it had to be canceled. So what does LESAR do to fix this problem? LESAR is a low-cost multifunctional rover, and you might hear me saying that a lot. But the way that I keep it at low cost is, first, we have it at a more focused mission scope. We have our bigger rovers that have a mission scope, but they're a little bit more broader than other things. So having a specific mission scope will make it more narrowed down to the kind of things we need to prepare for it. In addition, it will be a lot shorter mission duration so that the time it takes to develop those are smaller than it would take for a Perseverance rover. That way, it's also easier and faster to develop and then to deploy onto a planetary surface. LESAR is to provide an early stage reconnaissance mission. So rather than replacing a rover, we're putting it into a prerequisite where it scavenges for data and identifies areas of high scientific value, where when we're constructing our other rovers, we get data back and we're saying, okay, well, we can change this instrument, we can change this thing, we can maybe go to this area since it has more of what we need. So overall planning. And since it's a low cost, we can deploy it in larger numbers, covering more area at once. Here we maximize the impact of future space missions by, instead of having an idea and putting our money into it, we have a more focused and more simplified area of where we're putting our money, and we're getting the more bang for our buck. And in addition to space exploration, I've also found that it can be good in precision agriculture, which I will get to later. One of the most important parts of designing, of course, is the considerations we take for it. I found this very interesting. As I said, I like to do art, so I like to sketch a lot, and I found it fun to start sketching out my rover and making adjustments to it here and there, and just considering all the things that you may need for a certain rover. Starting off with the mission scope, as I said, it's more focused, and since this was a science fair project, I had to kind of narrow it down to the ice and water detection, which I learned was important through Artemis 3's science mission report, where they talked about a lot of various things that they were looking for, and ice and water detection being one of them. Knowing my mission scope, I was able to pick out certain instrumentations. For example, I picked out a gas sensor, moisture sensor, and an NPK sensor for enhancement, which senses the nitrogen, phosphorus, and potassium, and those are very important elements for plant life. And knowing that we want to have a permanent lunar base someday, the cost of sending food and water over to space is extremely expensive, and even if we find just a small amount of NPK on the surface, we can build onto it and then someday have a farm, I guess. Of course, the cost, I had a fixed budget, which means for my structural design, I had to reuse parts from old robotics projects, and I kept it at a fixed budget of around $300. Even though I couldn't really incorporate much of the space-like materials onto my rover, I did do a lot of research on lightweight design and the thermal and radiation shielding. Before I jump into power, one of the things that started to stand out to me was that every design consideration influences another one. It's kind of like a knobs, if you take it for example. If I have a lighter weight design, then I can use less power. I don't need to put so much effort into something that's so light. And then the other way around, so you get the idea. For my power, I decided to use solar panels since it was a more lunar-based mission. Because the moon is in a closer proximity to the sun, we can rely on solar panels. But for something like a Mars mission, we might require MMRTGs or nuclear generators. I also planned on doing redundancy, so I have a solar panel and then a battery that's connected to my main Wombat controller, which controls the movement of the wheels and the servos of the arms. In addition, now, one of the things that I had to keep in mind is that in order to keep it low cost, I can't reinvent everything. I have to keep some things that are already made, and that way it'll keep it at a low cost. For example, the navigation, there are missions that are autonomous and semi-autonomous. My vision for LESAR was to have pre-downloaded routes onto it and then have a semi-autonomous configuration where from here we can control parts and bits. But for missions like that would take place on Mars, you would have to have a more autonomous navigation system. I do use infrared rangefinder sensors, and I'm doing a LESAR, sorry, not LESAR, I'm doing a LiDAR sensor that's in progress right now. The same thing for delivery and communications. I planned on just keeping the same concepts that NASA has as now. For delivery, NASA relies on commercial launch services, and that would be the same way for LESAR. You would have a lunar lander send down the rover, and that would take it to the moon and back. For the communications and data, I have an Arduino board on my robot, and that has a Wi-Fi chip inserted into it. That is how I imagined my communications being, through the Wi-Fi to other rovers that may be on the moon at the same time, and then to the lunar lander, in which the lunar lander would connect through NASA's Deep Space Network to get down to us today. Here are just some overview of what I explained, but I'd rather show you this in my picture form. So here are just some pictures of the rover that I have. If you'd like to check it out more, I'm down over there at booth 306. I have a Wombat controller, which is one I borrowed from my robotics projects, and an Arduino controller that manages the sensors. My Wombat controls the wheels and the servos to allow the arm to move down and allow the robot to move around. The solar panels and battery, I have, like I mentioned, the solar panels are over there, and then a redundant battery for the Wombat controller. For my navigation, as I said, the IR rangefinder sensor, and then the LiDAR sensor is a work in progress as of now. For my instrumentations, as I mentioned before, a gas sensor, temperature sensor, NPK, and a moisture sensor, since the objective of the mission is to scout for ice and water. Here are just some of my electrical schematics that I had to put much time and effort into put this online. I had to quite literally take the top off my Rover to trace all the lines again. But this is just a quick overview. With the sensors, I did take some results. This is just basic testing though. Of course, I was more focused on the concept of a low-cost rover rather than how accurate these sensors are. Since they are commercial off the shelf off of Amazon, they may not have the best accuracy, but the point is to prove that this project can work in an environment. Now, one of the main things that I learned from this project is that the more you research, the more you realize there's so much more to everything. Everything that I researched had something more kind of that you had to deep dive more into, and then it has its own set of categories and everything. I also have such a great respect for all of you today who do this work every day, and I find it so fascinating, and I'm really excited to learn more from you guys for the rest of the day. Again, the design trade-offs, that everything is interrelated to each other. Because no matter if I change one thing, another thing will always adjust to that, and I have to find a way to make it all balance. And finally, when designing anything, we have to make it faster, better, and cheaper. But for mission-critical projects like this, it's wise to pick the two of them. In my case, I picked faster and cheaper, as LESAR doesn't have a more sophisticated instrumentation than you would see on a regular rover, but it does get us the data we need to get to that point. Again, thank you so much all for listening today. If you have any questions or any more suggestions for me of what you think I should do for this project, I'd be glad to answer them. Yes. No, this was an independent project I did. Of course, I had help from my parents, of course. Yeah.
Is there interest in having something like this as a school, broader program at your school?
Well, my school is a very STEM-based school, so we have a lot of robotics programs, as I've said before. My teacher was very nice to help me with some of the controls and the managements, because she worked with these controls more than I did, and she is a computer science graduate, so I got a lot of help from her. She was very kind to help me with that. Thank you. Yes. Right. I would definitely have to change I think the way that my wires are right now, it's kind of very scattered out. I've tried to contain it as much as I can, but then I have to make sure they're all kind of put together nicely so it doesn't interfere with anything. Some of the materials and maybe even the sensors might have to have some sort of shielding around it. But that's some of the things I've thought out for now. Thank you. All right, thank you guys so much for your time.